So the question I'm trying to answer is whether or not I can find the water pressure in my hose. So here I'm shooting the water vertically up from the bottom of my backyard and walking up the stairs to see if I can get up to a height where the water will stop coming out of the hose. But spoiler alert, that didn't happen. It kept shooting out of the hose when I got to the top. So I measured the distance from the porch down to the bottom of the backyard, and it's 16 feet. And then here I'm shooting the water horizontally, projectile motion, and I'm gonna measure that distance. So I've changed my objective from finding the water pressure to finding the horizontal velocity of the water when it shoots through the hose. So the distance I'm about to show on here is 11 feet-ish, but I went back and looked at the previous video and it was shooting a little further. So in my calculations, I used 13 feet instead.
And when I shot the water horizontally, I tried to match up the height at which I was aiming the hose with the position of the base of the hose on my house, and then I measured that, and it was about 29 inches.
Originally, the lady on this blog I found online said you could figure out the water pressure in your hose by measuring how high you needed to raise the hose until no more water came out. And I think her reasoning was that you could use Bernoulli's equation. So you'd have atmospheric pressure be P2, and you're trying to find P1 and rho g y1 and rho g y2. So together, you'd measure like the change in height between the base of the hose and the top, where the velocity is 0. So then by the continuity equation, both V1 and V2 would be 0. So you'd be left with P1 equals rho g y2. But as I showed in the video, I wasn't able to get up to a height like that, even if that was how it worked. So then I shifted to kinematics. I used this equation, the second one. So obviously you split it up into the y and x variables. So I had Vy naught, acceleration in the y direction, delta y I measured, all shown in the video. So then I was able to find that the time it took, add a decimal there. So it took 0.394 seconds, and I was able to find Vx. So in conclusion, I wasn't able to find the water pressure, but I was able to find the velocity at which the water shot out in projectile motion. So some sources of error include the water. It doesn't like land at one point. It's kind of like spread out as it leaves the hose, so you can't get a super accurate measurement of delta x. Another one, I tried to put the hose at the level of where like it came out of my house and then measure that, but I eyeballed that, so that was probably off.